So we're now going to take a look at part 2 of this case study. And part 2 will demonstrate the application of parallel flux features to do something a little different. This time what we're going to do is we're going to download and store images from remote web servers. And we're going to show off some flux operators, a whole bunch of parallel flux operators, and we'll also show the bounded elastic thread pool. And I'll explain why you would use the bounded elastic thread pool. So as before, you can get this in the ex5 project in my reactive flux folder in my live lessons GitHub repository. So now we're back in my ex5 project again, except this time we're going to take a look at the second method under test, which is called test parallel downloads. As always, both these methods run in the background, and the main thread waits for them all to finish. So let's take a look at this one. Test parallel downloads. What that's going to do is it's going to call a method here that will emit a flux, or create a flux that emits URLs to download. So let's go take a look at that method. And here's what it looks like. So we have an array of default image names. So you can see there's quite a lot of them. These are all coming from my website. And for each of those names, we use the flat map operator to convert the name into a flux. So let's go take a look at that. So what we do here is we make ourselves a method that will convert a string to a URL. And then we're going to go ahead and take the string of names that we got here and split them by the comma. So we're going to end up with a flux of names that are based on the comma separator. If we go back up and look at these names, you can see that they're separated by commas here. So we have these little chunks of names. And we then take each of the names, we prepend the URL prefix to each name, and the URL prefix points to my Vanderbilt website, and we put the name there. So we're going to end up basically with a list of URLs. So we have a list of URLs that turn into a flux of URLs. So we have a flux of URLs here. And we then take as many as we asked for here. So M max size. In this case, we're just going to say take them all, but you could give a smaller number if you wanted to. And in fact, I probably should change that to be something more like this. Get URL flux, let's see, integer or int max size. And let's say we make that max size, if I could spell right. And then let's go up here where we actually call this thing. And we're going to put that in there. That makes it easier to change it without having to worry about this. I'll fiddle around with that later to get it to compile. I just need to put it in the right place. So what we do then is we convert that sequential flux of URLs into a parallel flux of URLs, and we tell it to run on the bounded elastic thread pool. So bounded elastic thread pool is the one that can expand and contract. These are blocking operations, so that's a good thing to do. And then what we do is for each URL in the context of the bounded elastic thread pool, we're going to go ahead and map it to a method called download and store image, which is defined in a helper class called download utils. And you can see what download utils does is it's going to take the URL and it's going to download the URL and convert it into an image object. And it does that by using this helper method, and this helper method just reads all the contents from that URL, puts it into a byte array, and that then gets tucked inside an image, and the image keeps track of the URL and the actual image data. And when we're done, we have this image that we downloaded, and we're going to go ahead and store it. And store is just a method that will add a file to the file system under the name that was part of the URL. So we go ahead and write that file into the file system. All that stuff takes place in parallel. We then go ahead and we record this information for each downloaded image. And looking at this thing, this should probably be a string buffer, not a string builder. And that's because I think it can be called from multiple threads. We don't want it to be corrupted. And so after all that takes place, we then merge the parallel flux back into a sequential flux. We print out the results the string buffer, and we then go ahead and collect all the images into a list, which we can do now because we're running sequentially, and then we go ahead and print out the statistics of that computation. And here's what it looks like. So we ran this before. So you can see this tells you what thread things are running in, thread 39, 32, 36, and so on. So we're downloading those images in separate threads. And then when we're all done, it tells us that we downloaded and stored 42 images, which is what we have on my website. So that's illustrating how you can use parallel flux in conjunction with the bounded elastic thread pool. And what will happen, it's surprisingly difficult to get this information out of Project Reactor, but if we could get the information, we would find that the number of threads in that bounded elastic thread pool would have grown to 42 in order to be able to compensate for the fact that there was blocking operations taking place. Or something, might not have been 42, but it would have been higher than the default. The default on this computer is 10, because I have 10 cores, but it would have grown larger to compensate for the fact that there was blocking operations taking place.